With 240 volts AC, we already have a nice, strong voltage to power our system. And for reasons I will show you in just a second, having this higher voltage actually lets us distribute power more efficiently. Now, to see how the math works here, let's say that we need to deliver 3,000 watts of power to a lighting truss with a bunch of fixtures. If we're using a 240 volt service, we divide 3,000 by 240 to see that we draw 12.5 amps. However, if we are on a 120 volt service, or half the voltage, you can see that the current draw doubles, way up to 25 amps. Now, this is a huge increase and immediately causes some issues for us. First of all, if we're on a 20 amp circuit, this is definitely going to put us over. But also consider that to deliver those 3,000 watts at 240 volts, we could do it with 12 gauge wires. At 120 volts, all of a sudden, we need more heavy copper to deliver that exact same wattage. If we're looking at a huge lighting system, this extra weight can add up quickly, especially if it's being loaded on and off of a truck all the time. So the ability to deliver the same wattage with less current and therefore smaller, lesser gauge cables is why we sometimes use 208 volts instead of 120. Now, this is really common to see on lighting distros. It's essential for powering large video walls and is also something audio companies sometimes do to power their PA systems. Now, it is possible to set up a 120 volt power distro to additionally provide 208 volts without using a transformer. And to understand how we end up at 208 volts, we have to remember that voltage is the difference between 2 points. And three-phase power that measures 120 volts across hot and neutral actually measures 208 volts across 2 hot legs. Now, the exact equation, how we end up with 208 volts, gets into some complex math that we're not going to cover here, but the idea is, since our 3 hot legs are 120 degrees out of phase, the electrical potential, the voltage, between 2 hot legs at any point is this higher voltage of 208. So instead of hot, neutral, and ground, we have 2 hot legs on this one connector, which gives us 208 volts. Using this higher voltage is a more efficient way to power our production, but it does require the PD to have that capability and for us to know which voltages we're sending where.